Imagine a golden eye hanging in the dark, vast and silent. Its mirrors shimmer like armor plates, catching light that has travelled for more than 13 billion years. They call it the James Webb Space Telescope, but it's more than a telescope. It's a time machine, a cosmic confession booth, an eye that looks straight into creation and saw something that shouldn't exist. When NASA switched it on, scientists expected confirmation, equations, comfort. Instead, the universe laughed. Since day one, Webb has been sending images that don't fit any theory. Galaxies too massive, stars too old, planets that appear and vanish, chemical fingerprints no one can explain. Every photo feels like the cosmos trolling us in 4K. We built an eye to understand the universe, and the universe replied, "Nice try." Because every time Webb looks deeper, reality cracks a little more. Maybe the Big Bang wasn't the start. Maybe physics isn't a rule book, just local gossip. Maybe something out there is watching us back. So tonight, we're diving into 6 real discoveries James Webb has made that science still can't explain. They'll get stranger, darker, and more disturbing as we go, until the last one leaves you questioning everything you thought you knew about space, and maybe about us. Before we unlock that cosmic vault, quick reminder, you're watching Crazy Science Stories, where the wildest discoveries of science become cinematic adventures. Hit subscribe. It won't make you immortal, but it might expand your universe for at least 15 minutes. Alright, the countdown starts now. 6 mysteries, 6 scientific headaches, each one more unsettling than the last. Let's open the eye and see what it saw. Picture this. The universe is only a few 100 million years old. No planets, no life, no heavy elements, just darkness, gas, and chaos. In theory, nothing complex should exist yet. It's the cosmic equivalent of a baby still learning to crawl. But then James Webb looks back into that darkness and finds skyscrapers. Because what Webb saw were galaxies. Massive ones. Bright, structured, fully formed giants. Born just 300 million years after the Big Bang. According to every textbook, they shouldn't exist. It's like discovering a newborn with a mortgage, a car, and a LinkedIn profile. For decades, cosmology had a simple story. After the Big Bang, the universe expanded, cooled, and slowly started to build stars and galaxies. Gravity pulled matter together grain by grain, a cosmic slow cooker that took billions of years. But Webb's infrared eyes pierced further back than any telescope before, and what it saw blew that timeline apart. Some of these galaxies are 10 times more massive than the Milky Way. In cosmic terms, that's a skyscraper rising in the Stone Age. Even worse, they're not rare. Webb keeps finding more of them, hiding in the deep field, images like cosmic photobombs. Scientists stared at the data and did what scientists do best: panic politely. The numbers were verified, the instruments checked. Still, the signal held. One researcher admitted, either the telescope is wrong, or everything we know about how galaxies form is. So what's going on? Option 1. Our physics is incomplete. Maybe the early universe was more efficient at forming stars, like nature running in fast forward. Perhaps dark matter, that invisible glue holding everything together, behaved differently back then. Denser, clumpier, more eager to build. Option 2. We've misunderstood the Big Bang itself. Maybe it wasn't the beginning, but a reboot, a bounce from a previous universe, recycling the ashes of an older cosmos. If that's true, these galaxies could be fossils from another reality that survived the reset. And then there's option 3, the fun one. Maybe Webb didn't just look back in time. Maybe it looked sideways, across universes, through a cosmic overlap we can't yet explain. Because if multiple universes really exist, if they brush against each other like waves, then some of what Webb sees might not belong to ours at all. Astronomers hate this theory. It sounds too mystical, too sci-fi. But privately, a few whisper about it anyway. Because when math fails, imagination takes over. Humour helps. One astrophysicist joked, "It's fine. The galaxies aren't too big. The universe is just too small." Another replied, "Cool, so the laws of physics are optional now." In the end, no one knows. The data stands. The models break. And the universe seems to be trolling us with impossible architecture. But here's the real problem. Webb isn't done. Every time it opens its golden eye, it finds more of these forbidden galaxies, and the pattern is too consistent to ignore. Each discovery is another cosmic punchline, another reminder that our species is still reading the first line of the manual. Because if galaxies this massive existed that early, it means the universe is older, stranger, and far more productive than we thought. It means gravity might not be the gentle sculptor we imagined, but an impatient engineer, building skyscrapers before breakfast. And if that's true, everything else changes too. The history of matter, the origin of stars, even the timeline of life. All of it gets rewritten. It's as if the universe looked at our neat equations and said, "Cute. Try again." The James Webb Telescope wasn't supposed to cause chaos. It was built to confirm our models, to make the universe behave. Instead, it broke them. And while scientists are still arguing over new theories, one quiet fact remains. The first thing Webb ever saw was a reminder that we are not in control. So now imagine this. If the telescope can find entire galaxies that shouldn't exist, what else might it uncover? Not billions of light years away, but right next door. Because the next time Webb looked around, it found something far smaller, far closer, and far more unsettling. A planet. One that winked at us, and then disappeared. 4 light years away, in the star system next door, James Webb saw something that made the world stop scrolling. A planet. Not just any planet. A Saturn-sized world orbiting Alpha Centauri A, the closest sun-like star to Earth. If confirmed, it would have been the most important discovery in decades. A potentially habitable world, practically in our cosmic backyard. For a few glorious weeks, the headlines screamed, "Webb finds a new Earth." Then, it disappeared. The signal was there 1 month and gone the next. No trace, no echo, nothing. Astronomers double-checked the data. They looked for instrumental errors, cosmic dust, even random noise. But every test came back clean. The planet had simply vanished. Imagine that. You spend billions building a telescope so powerful it can read the chemical makeup of an alien sky. And when it finally spots something promising, the universe deletes it like an embarrassed magician. At first, the explanations were mundane. Maybe it was a glitch, a background star mimicking a planetary signal. Or maybe it was a miscalculation, the kind that happens when light plays tricks through interstellar gas. Some argued the planet was hiding, passing behind its star in an orbit we hadn't mapped yet. But none of those theories fit perfectly. Webb's instruments are absurdly precise. If it was just a reflection or an orbital blind spot, the math would have caught it. The light pattern that first revealed the planet wasn't random. It matched a real object. Something solid, something big, and then it was gone. NASA tried to sound calm. The official statement was simple: an unconfirmed detection, which in scientific language translates to "we have no idea." Behind the scenes, astronomers were less composed. Some wanted to re-observe immediately, others warned against chasing ghosts. One astrophysicist reportedly joked, "Either we just lost a planet or it didn't want to be seen." It was meant as humour, but the idea stuck. Because when you stare at the data long enough, it starts to feel personal. The signal hadn't faded gradually. It had vanished in one clean drop, as if something had deliberately turned the lights off. Of course, no one wanted to say that out loud. Not in a world where aliens and science are allergic to being in the same sentence. Still, the thought hung in the air like static. What if the planet wasn't gone? What if it just didn't want to be found? Let's be clear. The Alpha Centauri system has always been a tantalizing target. It's the closest star system to ours, a pair of suns and a faint red dwarf, all within reach of our future probes. If there's a place where life might exist nearby, this is it. We've dreamed of it for centuries. And now, when we finally glimpse something there, it disappears. It's like your neighbour waving from across the fence, then closing the curtains forever. Theories multiplied. Some said the planet's atmosphere could be reflecting light irregularly, tricking Webb's sensors. Others suggested gravitational interference from the binary stars distorted its signal. A few even floated the wild notion that it wasn't a planet at all, but an artificial structure orbiting the star. Something metallic, reflective and transient. A space mirror, a solar sail, a machine. Again, no one dared say it publicly. But inside late-night conference calls and encrypted emails, the whispers grew. Because the pattern didn't behave like nature. One astronomer put it bluntly: planets don't vanish, data does. And yet, Webb's data was flawless, the calibration perfect, which means the problem wasn't the telescope, it was reality. Whatever that signal was, planet, shadow, or something else entirely, it left no trace. Just enough evidence to exist, and not enough to prove it. For now, it's catalogued as Candidate 7, a Centauri. The word candidate means scientists are still hoping it comes back. They're still checking, still staring into that patch of sky like someone waiting for a ghost to text back. But here's the part no one talks about. When Webb lost the planet, it didn't just lose light. It picked up something new. A strange chemical reading from another system not far away. Something faint, but undeniably organic looking. At first, scientists thought it was another glitch, another mirage, but this one didn't vanish. It grew stronger, clearer, more specific. It looked alive, and no one could explain why. James Webb wasn't built to find aliens. It was built to study starlight, to decode atmospheres, to measure the faint whispers of chemistry floating in space. But then it aimed its golden eye at a world called K2-18b and found something that made scientists drop their coffee. Floating in that planet's thick, distant atmosphere was a chemical fingerprint that didn't belong. It wasn't methane, or water vapor, or carbon dioxide. It was dimethyl sulfide, DMS, a molecule that, as far as we know, is produced only by life on Earth. To be precise, by plankton, microscopic organisms that fart out DMS as they float through our oceans. On Earth, this gas means life, the smell of the sea after rain, the invisible perfume of biology at work. But out there, 120 light years away, it means something else entirely. A mystery. When Webb spectrometer picked up the signal, the data looked clean, crisp, impossible to misread. Scientists ran the numbers again and again. Every model said the same thing. Something on K2-18b is releasing dimethyl sulfide. If that's true, it's the first real biosignature ever detected. The first sign of life beyond Earth. Not a rumour, not a UFO, not a blurry photo. Just chemistry. Hard data. If it's false though, it's the best prank chemistry has ever pulled. Because dimethyl sulfide isn't a gas that forms easily. It needs complex organic processes, the kind we associate with biology. Not volcanoes, not lightning, not random reactions in the dark. It's the cosmic equivalent of smelling cookies in a kitchen no one admits exists. Picture Webb sniffing the air of another world and going, "Someone forgot to clean their ocean." The discovery sent shockwaves through astronomy. Half the scientific community started cautiously celebrating. The other half started sharpening their skepticism. Maybe it's an instrumental artifact. Maybe it's a coincidence. Maybe it's something we don't yet understand. And that's exactly what makes it terrifying. Because the truth is, our understanding of what's possible keeps changing. Every few years, nature shows us something it shouldn't be able to do. Super hot ice, metallic hydrogen, bacteria that eat radiation. Why should life be any different? Still, scientists try to stay calm. They called it a candidate biosignature, which in scientific terms means we're excited but terrified of being wrong. To put this in perspective, K2-18b is not a gentle place. It's a sub-Neptune, a world covered by a deep ocean beneath a thick hydrogen atmosphere. Temperatures hover around what we call habitable. If life exists there, it's not walking on land. It's drifting, swimming, evolving in darkness, maybe under alien tides lit by a dim red sun. But that doesn't make it less real. Life doesn't need to look like us to exist. It just needs chemistry. And now, for the first time, we might have found it. The irony is that James Webb wasn't even looking for life that day. It was studying exoplanet atmospheres, measuring gases, tracing how starlight filters through them. And yet, hidden in that data, there it was. The faint, stubborn signature of something alive. If that trace really came from living organisms, then humanity just became a little less alone. It wouldn't mean we're special. It would mean we're normal, part of a much bigger biological pattern written across the stars. But of course, the story doesn't end there, because Webb kept observing. And what it found next was even stranger. Something that didn't look alive, but behaved like it wanted to communicate. The telescope pointed deeper, toward a different kind of light. Not chemical this time, but rhythmic, pulsing, precise, as if the universe itself was trying to speak. In the catalogue, it's just a string of letters and numbers. WD0145 +2 3 4. Another cooling corpse in the endless graveyard of stars. A white dwarf, small as Earth, heavy as the sun, glowing faintly with leftover heat. It should be quiet, predictable, dead. But then James Webb looked at it, and the corpse started to blink. At first, the team thought it was noise, a twitch in the data, maybe interference from the detector. But the pulses kept coming, every few hours, sharp, timed, perfectly regular. Not random, not natural, too clean. Astrophysicists scratch their heads. Stars don't blink like that. They flicker, sure, turbulence, magnetic storms, dust, but never with this precision. This was rhythm, a beat, like a heart that refused to stop. Some called it magnetic resonance, the star's iron core vibrating in strange ways. Others proposed exotic matter, particles that shouldn't exist holding the remains together. And a few, the quiet ones, whispered the version everyone else was afraid to write down, the possibility that it wasn't a star at all anymore, that somewhere inside that ember was a machine still running its final program. Humor helped. If it's a message, one researcher said, let's hope it's not cosmic spam. Congratulations, you've won a new black hole. Everyone laughed a little too loudly. Because every few hours the pulse is repeated. Same pattern, same spacing, as if waiting for someone to notice. The data looked like information, ones and zeros wrapped in starlight. But when the team tried to decode it, the result was maddening. Structure without meaning. Order without purpose. Whatever WD 0145 plus 234 was doing, it was deliberate. But deliberate doesn't always mean intelligent. Webb kept watching. The pulses strengthened, then faded, then returned like a heartbeat echoing through space. And as they faded, the telescope caught something else, a faint shimmer behind the star. Not light exactly, but absence. A hole in brightness, a distortion of background galaxies, as if space itself were bending. Scientists dismissed it as lensing at first, but the alignment was wrong, the curvature off. The void behind the star wasn't caused by gravity, it was caused by something else. Imagine peeling paint from a wall and finding a crack running underneath. That's what it looked like. A fracture in space-time. Thin but endless. Suddenly the pulses didn't seem funny anymore. What if they weren't a signal from within the star, but a side effect of something breaking behind it? What if the light wasn't communicating, but warning? The idea spread through labs like static. The dying star might not be the story, the background might. Because when Webb looked past WD 0145 plus 234, deeper into that strange distortion, it saw the edge of something vast and cold. A shadow carved across the cosmic microwave background. A scar that shouldn't exist. And that scar has a name. The Eridanus Void. Messages hidden in dying stars are one thing. But when Webb looked further, beyond those stars, into the darkness itself, it found a wound in reality that no theory can heal. The deeper James Webb stares, the older the light becomes. And the older the light, the stranger the story it tells. When scientists stitched together the telescope's maps of the cosmic microwave background, they noticed something that didn't belong. A vast circle, colder than the rest of the sky, smooth as glass, empty as a forgotten thought. It's called the Eridanus Void, and it's enormous. Billions of light years across, big enough to swallow thousands of galaxies. Too big, too empty, too perfect to be random. Most voids in space are messy, uneven pockets where matter simply never gathered. This one isn't. It's surgical, round, precise, as if someone pressed a cosmic thumbprint into the fabric of reality. Temperature readings show that the background radiation there drops more than physics allows. It's not just less hot, it's wrong. Cosmologists argue over it the way archaeologists argue over a ruin. Some think it's the aftershock of two universes colliding long ago, a scar left when our cosmic bubble brushed against another. Others call it poetic things. The bruise on God's cheek, the cold kiss of creation. And then there are the pragmatists who shrug and say it's probably just data noise. Those are usually the ones sleeping worst at night, because the data won't behave. The cold spot appears across instruments, across decades, across missions, COBE, WMAP, Planck, and now Webb. Each new generation of telescopes measures it more clearly, and each one confirms the same impossible geometry. Basically, the universe has a dent, and cosmologists are trying to buff it out with equations. To explain it, they've built models full of exotic ideas. Some invoke dark energy currents, flowing like invisible tides that stretch space-time. Others imagine texture defects, wrinkles left over from the universe's birth. And then there's the boldest idea of all, that the void is an inter-universal boundary, the bruise left when two realities touched, like bubbles colliding in boiling water. If that last theory is right, the Eridanus void isn't empty at all. It's full of something we can't see. Another universe still pressing against ours. James Webb wasn't designed to find parallel worlds, but its instruments are sensitive enough to notice the tiny gravitational ripples that voids leave behind. In the direction of Eridanus, those ripples don't line up. Galaxies on one side drift slightly faster than they should, as if pulled by something beyond the observable horizon. To scientists, it's the closest thing physics has to a ghost story. The equations work everywhere else, except here, where they whisper about forces outside the map. Every time Webb looks into that cold abyss, the same unease returns. Maybe this isn't just an ancient scar. Maybe it's a window, one that doesn't only let us look out. And that brings us to Webb's strangest observation yet. Because after mapping that cosmic bruise, the telescope picked up something new, a pattern of light too regular to be random, too intelligent to ignore. What it found next would shake everything. Not just what we know about the universe, but what we think it knows about us. So if that's true, then somewhere beyond that scar, there could be another sky looking back at us. And in the next chapter, we'll talk about what James Webb might have seen blinking through the dark, the signal that shouldn't exist. In early 2025, James Webb detected something faint, almost nothing. A flicker of light repeating at regular intervals. At first, the team assumed it was noise, a calibration error, maybe sunlight bouncing off space junk. But the pattern didn't stop. It kept pulsing. Clean. Sharp. Deliberate. Too clean to be chaos. Too structured to be coincidence. The signal came from deep space beyond any known source. The rhythm was constant, the intervals precise, like a heartbeat echoing through vacuum. When they converted it into sound, it wasn't random hiss. It was order. Almost music. Every known law of nature screamed no. Stars don't blink like that. Pulsars wobble, quasars flare, but nothing in the cosmos beats in this perfect mechanical time. The pattern was unmistakable. A pulse every 142 seconds, stable for weeks without variation. No natural object we know can do that. Some said malfunction. Others whispered about reflections. An echo from one of our own probes lost decades ago. caught in an orbit we'd forgotten. But the signal was too strong, too distant, too old. And then someone noticed something stranger. The pattern, the sequence of pulses, looked familiar. Months earlier, another anomaly had passed through our solar system. An interstellar object known as 3I/ATLAS. If you've watched our dedicated episode on it, you'll remember the mystery. A rock that glowed too bright, moved too fast, and changed direction without reason. Some scientists said it was just a comet. Others thought it might be a relic of alien technology drifting through the stars. Now Webb had found a rhythm in deep space that matched the same reflective pattern recorded from ATLAS before it vanished. Different sky, same signature, the same cosmic heartbeat, repeating from light years away. That's when speculation turned to fear. What if it wasn't two separate mysteries? What if it was one, the same phenomenon seen from two sides of the universe? The object passing through our system, and its echo now answering back. Webb kept watching, recording, measuring. The pulse continued for 73 hours, unwavering, flawless. Then, just like ATLAS, it stopped. No fade out, no decay, just silence. The data team replayed it again and again, hoping to find a natural cause. Some proposed that it was a fragment of an ancient megastructure, a Dyson sphere long dead, still reflecting light from its collapsed star. Others argued for a quantum echo, a mirror effect bouncing across the cosmic scar we now call the Eridanus void. But a few scientists started to ask the question everyone else avoided. What if this wasn't something we received? What if it was something that noticed us? Humour kept the panic at bay. Maybe someone out there is waving, one researcher said, and we're replying with a PowerPoint. Everyone laughed, but no one deleted the data. Because deep down, the numbers felt too intentional, too exact. If it was a message, it didn't come in words. It came in light, a cosmic metronome tapping against the edge of comprehension. Maybe it wasn't meant for us at all. Maybe it was just proof that someone, somewhere, once, existed long enough to leave a rhythm behind. For centuries, we've watched the sky begging for answers. We built telescopes, radios, satellites, hoping for a signal that would prove we're not alone. Maybe James Webb didn't find secrets. Maybe it found witnesses. We built an eye to study the universe, a perfect golden mirror to catch the oldest light, to turn chaos into understanding. But somewhere along the way, something shifted. Because now, when we stare into the dark, it feels like the dark is staring back. Maybe that's the real punchline. The further we reach, the stranger everything becomes. We thought we'd find order. Instead, we found paradoxes, whispers, and shadows that shouldn't exist. 6 discoveries. 6 puzzles that refuse to stay solved. So what are they? Glitches? Coincidences? Messages from the infinite? We don't know. Maybe we never will. But that's what makes it beautiful. The idea that the universe still has a sense of humour, that it still knows how to surprise the smartest species it ever produced. Because behind every equation, every telescope, every data point, there's the same question echoing through human history. What if? And maybe, somewhere out there, the universe is asking the same thing about us. This was Crazy Science Stories, where the strangest discoveries of science become cinematic adventures. Subscribe and join us for the next impossible mystery. Because somewhere out there, the universe is already writing our next episode.